Factoring. This first lesson, we'll look at factoring using the greatest common factor, or GCF, grouping, and difference of squares. These three types of grouping should have been covered in Algebra 1. Coming off of some of these COVID years, you may or may not have gotten to this. So first up, we're going to look at GCF. You need to remember that factoring is simply rewriting an expression as a product of prime factors. The greatest common factor is the first step when factoring. No matter what type of factoring you're doing, you should always look for the GCF, or greatest common factor, first and remove it to make your problem easier. An example we have is 3x plus 6. You have two terms. Okay? Now what we want to do is we want to find out, do the terms have any common variables? I've got an x and a 6, so my answer would be no. Is there a real number that is a factor of both terms? That means a real number, an integer, that will go into both 3 and 6 evenly. Absolutely. 3 is a factor of both 3 and 6. Now, what do we do with that? Well, we divide each term by 3, or we rewrite it. So I'm going to take the 3 out, and notice that when I take the 3 out front, I have to divide by 3 each factor. And then I simplify the terms inside, So now I have 3 times x plus 2. You have factored, okay? We've now rewritten the expression as a product of its factors. If I distribute the 3 back, I would get 3x plus 6, which is what we started with. Let's take a look at another example. What if I want to factor 5z plus z? I have two terms again. And do they have any common variables? Well, yes. I've got a z squared and a z. So z is a common variable. So if I divide both of these by z, factor out the z, means I factor it out here, take it outside, put parentheses around the rest of it, divide each term by z, I wind up with z times 5z plus 1. Is there a real number or an integer that is a factor of both terms? I have 5z and 1. Only 1. And 1 doesn't change anything. So I'm done. I have factored this. It's z times 5z plus 1. Remember that when you do greatest common factor, you have to give me the greatest common factor and the remaining or resulting polynomial. Now, take a moment and pause the video and try these problems. Okay? Take a moment and try these. You're going to factor out the greatest common factor of each. Did you pause the video? And did you try each one of these? All right, let's go through them. And if you were getting stuck, go ahead and watch the solution for the first one or two. And then if you were stuck on some of the later ones, pause the video again and try those. So let's see this first answer. This first answer is 2 times 3x. Let's see if I can move this down here a little bit. Okay. Squared plus 7x minus 15. 1, 2. So what I did is I realized I've got 6, 14, and 30. So I can get a 2 out of each. And then I'm going to divide each one of these by 2. 6 divided by 2 is 3, and I still have the x squared, plus 14 divided by 2 is 7, and I have the x. The minus comes down. 30 divided by 2 is 15. I go back and I look. I have an x squared and an x, and there are no variables, so there's no common variable to all three terms. Okay, let's look at this next one. Oops. Here's your answer. How did I get it? Well, in looking at this, I've got 4, 8, and 28. I know that 4 will go into everything. I've got an x cubed, an x squared, and an x. X will go into everything. So I've factored out the 4x, and then I have to go through and divide each term by 4x. So now I've got my greatest common factor here. Then 4x cubed divided by 4x is x squared. The sign comes down, the minus. 8 divided by 4 is 2. X squared divided by x is x. Then 28x divided by 4x is 7. This one. What will go into everything evenly? Well, I've got 9 and 18, so I know 9 will go into all the terms. A to the 6th and a squared. I take the variable and then I use the smallest exponent, which happens to be 2. Over here, it was 1. Okay? So then I'm going to divide each term by my 9a squared. And I'm going to the result is a to the 4th and 2. And the 9a squared is out front. Again, if you were struggling a little bit with those, pause the video and finish these last 3. Okay. All right, let's take a look at these answers. I'm only going to do one more in the video, and that's because, well, this one gets a little tricky. We have 21xy cubed, and actually I'm going to move this over here so that I can write better. I've got 21 and 7, so 7 will go into both terms. X and y cubed, x and y. I can get an x out of everything and a y out of everything. So I divide everybody by 7xy. And this is something that you want to do when you're taking a test or a quiz, because notice that 21xy cubed, 21 divided by 7 is 3, x divided by x is 1. So I don't write a 1 down because otherwise it would look like 31. Then y squared divided by y is y squared, plus 7xy divided by 7xy is 1, not 0. You have to put a 1. Why? Because if I go to multiply back, 7xy times 3y squared is 21xy cubed. Okay, if I multiply this back to check it, I have to have this 1 here so that I can multiply the 7xy by it. It's a placeholder for it. This is the most commonly made mistake by students first factoring, is they'll factor out the 7xy, fantastic. But then they put 3y squared instead of 3y squared plus 1. Don't forget the 1. Okay. Over here, this one should have been fairly easy. You just had a number that came out. And over here, you had the 4x. This is similar to the second one. Now, the thing that you need to know is that when you're factoring, you can multiply your solution back together again, and you should have what you started with. So if we look at this, 6x cubed minus 3x squared plus 18x. What can come out of everything? Well, I can get out a 3. And then I've got an x cubed, x squared, and an x. So I've got a 3x that I'm going to divide everybody by. So I do that. And here's my answer. Ding! Now, I want to check it. So what I'm going to do is I'm going to multiply it back together again. So I've got 3x times 2x squared minus 3x times x plus 3x times 6. I've taken my greatest common factor and I am distributing it over each term of the trinomial. 3 times 2 is 6. X times x squared is x cubed minus, this just comes down, 3. X times x is x squared. Plus comes down. 3 times 6 is 18, and I have an x. this answer should be the same as what I started with, and it is, so it checks. Go ahead and try these next two. Do the greatest common factor and then multiply the greatest common factor times the polynomial to see that you get the original back. Pause the video. Let's look at it. Okay, first off, this is what you should have gotten when you factored. If you had trouble with this and you don't understand why after looking at it, please get with me. Otherwise, we're just going to go ahead and do the multiplying. So here, I factored this. Notice 15, 3, and 25. No common numerical. Z to the fourth, z squared z. I got out a z. So now I'm going to distribute the z back to all three terms. So this is going to be z times 15 z cubed plus z times 3z plus z times 25 is just 25z. Here, z times 15z cubed is 15 z to the fourth plus z times 3z is 3 z squared plus 25z. This checks with that. They are the same, so it checks. I have the correct answer. Now, I have a factored answer. The one thing that checking doesn't do is it doesn't make sure that you have factored it completely. Okay, like over here, if I only took out a 3 and I didn't take out the x, I could check and I would prove to myself that I did factor it correctly. I just might not have completely factored it. And your answers must be completely factored. Over here, 8xy. And if I multiply this back, don't forget that 1 out there. If you forgot the 1, you wouldn't be able to multiply back. Okay. You're going to get 8xy times 2x squared y cubed plus 8xy times 3xy plus 1 times 8xy is just 8xy. 8 times 2, 16x times x squared is x cubed. Y times y cubed is y to the fourth plus 8 times 3 is 24. X times x is x squared. Whoops, I forgot my little squared there. Y times the y squared is y cubed, and you have your 8xy. And my answers check. Okay, so multiplying factors together should result in the original polynomial. Grouping. This is the second method. Factoring by grouping is simply factoring the greatest common factor twice. Let's look at an example. If we take x cubed minus 4x squared plus 3x minus 12. First, this is by grouping. We have 4 terms, not 2 terms, not 10 terms. We have 4 terms. And when I look through them, they don't all have a greatest common factor. So I'm going to group the first 2 and the last 2. Then I'm going to take out the greatest common factor of the first 2. So x cubed, 4x squared, I can get an x squared out, and that'll leave me with x minus 4. Notice if I take an x out of each of these, that's how, oops, an x squared out of each of these, that's how I get x and minus 4. Then for 3x and 12, 3 is common to both. Okay. So I take the 3 out and I get x minus 4. Now here's where you should notice that I have x squared times x minus 4 plus 3 times x minus 4. The x minus 4 is the greatest common factor of these 2 terms. So I can take it out. When I divide this whole side by x minus 4, I get x squared. When I divide this whole side by x minus 4, I'm left with 3. So that's where your 3 came from, and that's where your x squared came from. And you're done. It's just doing greatest common factoring twice after you group them. Now, Let's try some of these. Let's try 2 of these together, and then I'll let you try 2 on your own. So for this first one, I've got 4 terms. There's not a common factor in all of them. So I'm going to group the first 2, and then I'll group the second 2. Then I'm going to look here, 6 and 21. I can take a 3 out. And then I've got a v cubed and a v squared. So I'm going to take out a v squared. And that's going to leave me with 6 divided by 3 is 2. V cubed divided by v squared is v. Plus 21 divided by 3 is 7. V squared divided by v squared is just 1. Then this sign in the middle comes down. Now 4v and 14, I can take a 2 out of both of those. And they don't both have a v, so I can't do anything else. So I'm going to get 4 divided by 2 is 2v, plus 14 divided by 2 is 7. Now, notice I have 2v plus 7 and 2v plus 7. That's my greatest common factor. 2v plus 7, greatest common factor. Well, when I take it out of here, what's left? 3v squared. When I take it out of here, what's left? The plus 2. And I'm done. Okay, that is supposed to disappear. There we go. Okay, let's try this one over here. Now this one has one thing that's going to be a little tricky, and we'll get to it. When I group, first off, 8, 48, 1, 6. Not the same, they don't have an x. So I'm going to group the first 2, and then I'm going to group the second 2. But notice there's a minus here, so I'm going to have to change this sign. Remember that if I have minus x plus 6, that's equal to negative x minus 6. Why? Because if I distribute that negative, I get negative x plus 6. So here you have to change that in here. Anytime you have a minus in the middle, you're going to have to change the signs. If it was plus, you make it minus. If it was minus, you make it plus. Now, continuing on, 8 and 48, I can take out an 8. X cubed, x squared, I can get out the x squared. 8x squared, 8x squared. So now I have 8x squared. Let's put this in a different color, huh? 8x cubed divided by 8x squared is x, minus 48 divided by 8 is 6. X squared divided by x is just 1. Now I bring down my subtraction sign, and now I've got x minus 6. Well, the only thing common here is 1, and I'm going to go ahead and write the 1 down. Now, what does that leave me inside the parentheses? X minus 6. Okay, notice what's in purple here. X minus 6, x minus 6. That is my greatest common factor. I have a binomial greatest common factor. Then, to get my other factor, I have the 8x squared and the minus 1. Because if I factor this out, if I cancel this out and I cancel this out, 8x squared minus 1 is what's left. Okay? Now, you have 2 more to try. So go ahead and try these and see what you get. Oops, I'll leave this like this so you can see the work. Both of these have pluses in the middle, so you don't have to worry about this situation for now. Okay, are you back? So how did you do? Are you successful? Okay, we're going to run through this kind of quick because if you have questions, you can ask me in class. But let's go through here. I'm going to group the first two and group the last two. Over here, 12 and 18, greatest common factor, 3. X cubed, x squared gives me an x squared. 3 goes into 12 4 times, x squared goes into x cubed x times, plus 3 goes into 18. Oops. Now here's something I want to show you, 6. X squared goes into x 1 time. What happened here? Yes, and it's okay. Sometimes when you first see a greatest common factor, you think you've got it, and then you factor, you notice that you didn't get a big enough one. I can take out another 2. So if I take out 2, 2 times 3 times 2 is going to be 6, x squared. Now I have 2x plus 3. I want to show you that it's okay to sometimes not get it right the first time you pick your greatest common factor, as long as you stop and look at what you did. Okay? Then I have plus 10x and 15. I can get out a 5, and that's going to leave me with 2x plus 3. Noticing that 2x plus 3 is the same. 2x plus 3 is the same in both of these. So that's going to leave me, okay, if I look at it, with 6x squared plus 5. Does it matter if I write it in this order or this order? Absolutely not. Remember that 2 times 3 is equal to 3 times 2. Both of these result in 6. It's the commutative property. The order of factors does not matter. Finally, over here, let's group the first two, and we'll group the last two. The first two here, we've got 40 and 24. You can take out an 8. A cubed and a squared takes out an a squared. It's going to leave me with 5a minus 3 plus, only 1 comes out, so it's 5a minus 3. Notice the 5a minus 3 is a factor, and when I cancel that out, I'm left with 8a squared plus 1. Fantastic. Okay, you'll have some more problems like this to practice. Are you ready for the final method of the day? Great. This is going to be the difference of squares, and it's nothing but a pattern. If you get something that is a squared minus b squared, it factors to a plus b times a minus b. And how does that work? Well, here I made a multiplication table. Notice that a times a is a squared. A times b is ab. Negative b times a is negative ab. Negative b times b is negative b squared. The negative ab plus the ab makes a 0 pair, leaving a squared minus b squared. So it's just a factor. It's just a factor. It's just a pattern. Okay? And of course, you always have to look for greatest common factor first. So let's get started. All right. First up here, we've got x squared minus 16. Well, x squared is a perfect square. 16 is a perfect square. So we get x plus 4, x minus 4. Remember, it's a pattern. A squared minus b squared is equal to the square root, the sum of the square roots, and then the difference of the square roots. 5x squared minus 125 is, 5 is not a perfect square. Oh, wait, greatest common factor. If I take a 5 out first, that leaves me with x squared minus 25. Now, I still have the 5. I can't lose that. But then the square root of x squared is x. The square root of 25 is 5. And then I do the difference. Does it matter if the sum or the difference is first? It doesn't. By convention, we put a greatest common factor out front. but again, it wouldn't make it right or wrong. 49x squared minus 36. Everything is a perfect square. So the square root of 49, 7x, the square root of 36 is 6. And then we have 7x minus 6. Once you get the first factor, the second factor is easy. Now over here, don't forget 64z squared. You can turn this around, but keep these numbers in the same order. 8 plus z. Now this one doesn't matter if it's 8 plus z or 8 minus z, but the second factor definitely matters. Okay, z minus 8 is not the same thing as 8 minus z. Got it? Great. All right, your turn. Take a moment, pause the video, and try these three. Okay, how did you do? Remember, square root plus square root minus square root, and in the green, this one here in the middle, you had to make sure that you took out the greatest common factor, which happened to be 3. Now, we're going to try a couple more. So again, pause the video and try these 3, or these 4, sorry. All right, how did you do? Now, one thing that I do want to mention, because, and I'm not just sure why or how sometimes students do this, but occasionally I will have students who will give me the factors like this. Okay, that's not how we write things. If I want to multiply 2 times 3, I don't do 2 times 3. This actually looks like I'm adding them. Okay, so don't do that. That's a no-no. Okay, whoops, don't do that. Put factors next to each other. You can stagger lines like this, but please put factors next to each other. The other one I wanted to mention is this one here, the y to the 6th, the square root of y to the 6th is y cubed. Remember, if you've got y to the 6th, that's the same thing as 1, which gives me y cubed times y cubed. So the square root of y to the 6th is y cubed. Got to remember your exponent rules from Algebra 1. And you supposedly did do exponent rules. Okay, over here, 1 is a perfect square. W is your variable. It's okay to have it second. Now, it's time for you to practice. So check your calendar and look to see what fantastic practice activities await you. When you have problems, be sure you ask in class.